So let's start with some past paper questions for the rational expressions, long division, remainder, factor theorem. This is all in chapter algebra of P3 maths. So let's start with a question from October, November 2023, variant 32, and this is question number 3. So it states that the polynomial 2x cubed plus ax squared minus 11x plus b is denoted by p of x. It is given that px is divisible by 2x minus 1, and then when px is divided by x plus 1, the remainder is 12. Find the values of a and b. So since we have two unknowns, we need two conditions, and they are giving us two conditions. So over here, we don't have to use a long division over here. We just simply have to use the remainder and factor theorem. So since 2x minus 1, the px is divisible by 2x minus 1, so the value that we have to plug in over here comes from allowing 2x minus 1 to go to 0. So when we put it equal to 0, x will come out to be 1 over 2. So now we plug in 1 over 2 inside, and 1 over 2 cubed plus a 1 over 2 squared minus 11 1 over 2 plus b, and that is equal to 0 because 2x minus 1 is a factor. Let's simplify this before we use the second condition. So 1 over 8 plus a 1 over 4 minus 11 over 2 plus b equal to 0. This becomes 4, so 1 over 4 plus a by 4 minus, since we're making the denominators 4, let's make this into 22 over 4, and plus b equal to 0. 4b over 4. So since 4 is the common denominator, it cross multiplies on the right hand side, and that becomes 0. So we are left with 1 plus a minus 22 plus 4b equal to 0, which can further be simplified as a plus 4b equals to plus 22 minus 1, 21. And this is our first equation. Now we go with the second one. It states that when we divide the px with x plus 1, that means when x is equal to minus 1, we will get the remainder 12 rather than 0. So let's plug it into that. So 12 will be equal to 2 minus 1 cubed plus a minus 1 squared minus 11 minus 1 plus b. So the cube of minus 1 is minus 1, so minus 2. Minus 1 whole squared is positive. Minus 11 times by minus 1 plus 11 plus b equals to 12. Now we simplify a plus b, and on the other side 12 plus 2 minus 11, 14 minus 11, that's 3. So this is our second equation. Now we have two unknowns, two equations, we just have to solve them simultaneously. So we have a plus 4b equals to 21, a plus b equals to 3. We subtract these two equations together. This cancels out. We are left with 3b equals to 18. So b will equal to 6. A plus b is equal to 3. So A would be 3 minus B, which would be 3 minus 6. That would be minus 3. So therefore, A is minus 3 and B equals to 6. All right, on to the next question. Okay, so this one is October, November 2023, variant 33, and question number 3 also. Okay, so the polynomial 2x cubed, it's a similar question, so 2x cubed plus ax squared plus bx plus 6, where a and b are constants, is denoted by p of x. Where when p of x is divided by x plus 2, the remainder is negative 38. So that means when we plug in minus 2, we get negative 38. And when p of x is divided by 2x minus 1, the remainder is 19 over 2. So 2x minus 1 means 1 over 2. 19 over 2. So just to be clear how the values of x are coming. So we plug in x plus 2 equal to 0, and x would be minus 2. And over here, 2x minus 1 equal to 0, x would be 1 over 2. So that's how we're getting these particular values. Now, we had two unknowns. Find the values of a and b. To find the two unknowns, we need the two conditions, and these are coming from these two conditions. So let's expand these. Uh, let's go with the first. Let's call this first and second. So let's start with the first one. So p of negative 2, so 2 of negative 2 times by negative 2 cubed, plus a negative 2 squared, plus b times by negative 2 plus 6. Let's simplify this. Negative 2 cubed is just negative 8, plus a times by 4 minus 2b plus 6, negative 16 plus 4a minus 2b plus 6 equals to negative 38. Let's keep 4a minus 2b on one side, and on the other side we have negative 38 plus 16 minus 6. So negative 38 plus 16 minus 6, so negative 28. Now, as you can see, we can further simplify this also. When we divide both sides by 2, this could become 2a minus b equals to minus 14. Either way, that represents the first equation. Now, let's go with the second one. P of 1 over 2 is 19 over 2. So 2, 1 over 2 cubed, plus a 1 over 2 squared, plus b 1 over 2 plus 6, and that is equal to 19 over 2. So 1 over 2 cubed is 1 over 8, so 2 over 8, plus a over 4 plus b over 2 plus 6. 2 over 8 is 1 over 4. So 1 over 4 plus a over 4 plus 2b over 4 plus 6 times by 4, 24 over 4. Since we can, make all the denominators same on both sides, we could also make this 4. So 19 times by 2, 38. So 4 on both sides cancel because it's same thing on both sides. So we are left with 38 is equal to 1 plus a plus 2b plus 24. So a plus 2b. So no. Yeah, okay. negative 38. So 38 minus 24 minus 1. So 38 minus 25, that is 13. And that's our second equation. Now, we need, actually, if we see 2b over here, we can use the this version over here. So we have minus 2b equals to negative 28, and a plus 2b equals to 13. Since we already have the numbers same, but signs are already opposite, so instead of subtracting them, we can just simply add them. So they will cancel out. 4a plus 5a, 4a plus a will become equal to 5a. Negative 28 plus 13 would equal to minus 15. So a would be simply negative 3. We can use either one of these equations to find out b now. So a plus 2b equals to 13. 2b will equals to 13 minus a, and b would be 13 minus a over 2. Therefore, 13 minus 3 over 2, 16 over 2, 8. So therefore, a is negative 3, b is 8. Okay, so now let's move on to the next question. Okay, so the next question is from May, June. So May, June 23, 3-1, and this is question number 10. Okay, so the polynomial x cubed plus 5 x cubed plus 5x squared plus 31x plus 75 show that x plus 3 is a factor of p of x. So all we have to do is to make x plus 3 equal to 0. That will give us x is equal to minus 3. So for it to be a factor, for x plus 3 to be a factor, p of negative 3 should come out to be 0. So let's test whether it comes out to be 0 or not. So when we plug in negative 3, so negative 3 cubed plus 5 negative 3 squared plus 31 negative 3 plus 75. So negative 3 cubed is negative 27. 5 times by positive 9, 45. Plus 31 times by 3, 93. Sorry, negative 93. And 70 plus 75. So let's add it up together. So negative 27 plus 45 minus 93 plus 75. So that is 0. So yes, x plus 3 is a factor of p of x. So that's about it. So the next part is the complex numbers part. So we're going to leave this. So moving on to the next question. Okay, so the next question is from May-June session also. May-June 2023. And the variant is 3, and question is 2. Find the quotient and the remainder when 2x raised to power 4 minus 27 is divided by x squared plus x plus 3. So over here we have to do the long division over here. So let's do the long division. Now, although it just says 2x raised to power 4 minus 27, the rest of the x terms are 0. So we can write it as 2x raised to power 4 plus 0x cubed plus 0x squared plus 0x minus 27 divided by x squared plus x plus 3. Now, let's start off. To make it into 2x raised to power 4, we need to multiply with 2x squared. So 2x squared, that becomes 2x raised to power 4 plus 2x cubed plus 6x squared. Subtracting. Negative 2x cubed, negative 6x squared, and plus 0x. So to make it into 2x cubed, we need to multiply with negative 2x. So negative 2x squared, those are cubed, negative 2x squared, and 6x negative. So, sorry, again, subtraction, plus, plus, plus. So this would become negative 4x squared and plus 6x minus 27. So we just need to multiply by negative 4. So negative 4x squared, negative 4x, and negative 12. So same thing, we subtract. This cancels out. 6 plus 4 is 10. And 27 minus 12 is 15. So that's our remainder. So when we are dividing this, let's make it a little bit neater. Quotient coming out to be 2x squared minus 2x minus 4, and remainder is coming out to be 10x minus 15, and we have x squared plus x plus 3. So either we clarify that the quotient is 2x squared minus 2x minus 4, and the remainder is 10x minus 15, or we can also leave it in this form, but if we keep it explicit, that would be better. Okay, all right, on to the next question. The next question is from February-March 2023. So February-March 23, variant 32, question number 3. The polynomial 2x raised to power 4 ax cubed plus bx minus 1 is denoted by px. When px is divided by x squared minus x plus 1, the remainder is 3x plus 2. Find the values of a and b. Now, it's something very intuitive over here, that we don't necessarily have to go through the long division over here or remainder factor term. Obviously, we are actually using that, but all it's saying that when this polynomial plus bx minus 1 is divided by x squared minus x plus 1, we are getting some quotient, and the remainder is 3x plus 2 over x squared minus x plus 1. So that's what it's telling us. Or we can write it in a different, like we can rearrange this also. Now, one thing to notice over here, since we're dividing a polynomial of order 4 with the order of polynomials 2, the quotient that we will get will be of a quadratic nature, quadratic polynomial. So when we rewrite this, we could write it as a and b are already used, so we could use, let's use the capital ax squared plus bx plus c. So we're actually getting something of this form over here. So when we rearrange this, we can rewrite it as 2x raised to power 4 plus ax cubed plus bx minus 1 is identical to ax squared plus bx plus c times by x squared minus x plus 1 plus 3x plus 2. Now let's expand the right hand side. So ax raised to power 4 minus ax cubed plus ax squared plus bx cubed minus bx squared plus bx plus cx squared minus cx plus c plus 3x plus 2. Now let's collect the power terms into one, coefficients. So there's only one power 4 term, x raised to power 4 term. But the cubic terms are this. So we can lump it into b minus a, x cubed. Then we look at the square terms. A minus b plus c, x squared. Then we have the x terms, bx minus c plus 3. So b minus c plus 3, that is x, and plus constant is c plus 2. Now, we are saying that this is identical to 2x raised to power 4 plus ax cubed plus bx minus 1. Now all we have to do is to compare the coefficients. So when we compare the coefficients, a is identical to 2, which this is a very straightforward observation. A, small a, is equal to b minus a. We know the a, but we do not know b, so let's keep on going. B is a minus b plus c, too many unknowns. Minus 1 on the other, wait, sorry, no. Oh, we did not have the square term, sorry. This is not equal to b. We have, sorry, b was equal to b minus c plus 3. And minus 1 is equal to c plus 2. So let's start with the, this is done, like this we already now know. Let's start with the c, because c has the least unknowns, like one unknown. So c would be minus 2 minus 1 minus 3. So we have found this. Let's use a and c to figure out what b is. One thing which we did not write over here is if x squared term is 0, then that would mean that a minus b plus c is equal to 0. So this is also a valuable piece of information. We have found A, we have found C. So we can find out the B very easily. So B is equal to A plus C. So that is 2 minus 3. That is equal to minus 1. So B is equal to minus 1. Now that we know capital B, we can find out the small b also. So small b is equal to minus 1 minus 3 plus 3. So cancels out. B is equal to minus 1. So we have found one of the unknowns required. Now we need to find out the A. So A is equal to B minus A. Capital B minus A. Capital B is negative 1. A is 2. So that is negative 3. Sorry, I just realized something. In this one, for the B, we had minus C over here. So C was already negative. So minus 3 plus 3. So this actually becomes minus 1 plus 3. That would be 6 minus 1, 5. So therefore, final answer is A equals to 5. B is equal to negative 3. So that's it for the 2023 questions. Hopefully next time we will start out with the next subtopic in the algebra, and that would be partial fractions. Take care.